Hi pre-calculus students. In this video I'm going to be doing some examples of lesson 5.4, sum and difference formulas. So hopefully you'll find this helpful. By the end of this lesson you should be able to evaluate the exact value for non-standard trig angles using the sum and difference formulas that we're learning today. So in this section, we will be working with trig identities that help us express sum and differences of values of sine, cosine, and tangent. We'll use these formulas to evaluate the exact values of non-standard trig angles. What's a non-standard trig angle? It's an angle that's not a special angle, so it's not a multiple of 30, 45, or 60. So a non-standard angle might be something like 50 degrees. Because we don't have a special right triangle for 50 degrees. We will refer to the unit circle throughout this section. So it'd be helpful if you opened up a copy now. You can find a link to the unit circle posted in the assignment for 5.4, or you can simply Google unit circle and many options should come up. So here are the three formulas. You want to write them down. You'll notice that the sine formula has a plus then a minus, and then a plus then a minus. That means if you're adding two angles together, you add. If you subtract two angles, you subtract. If you use addition, stick with addition. If you use subtraction, stick with subtraction. If you take a look at the cosine formula, cosine x plus y equals the cosine of x times the cosine of y minus then plus. That means if you add, you do the opposite and you subtract in the formula. If you subtract here, you do the opposite and add in the formula. And then the tangent formula is the trickiest one. Tangent of x plus or minus y is the tangent of the first plus or minus, same as you use here, the tangent of the second over 1, and then the opposite of what you used here. Okay, so you want to write those down, so you want to pause this and get those copied down. And here are your steps for using the formulas. So to find these exact values that we're looking for, first thing you're going to do is you're going to split the given number into the sum or difference of unit circle values we already know, which I'll explain a little bit more in an example. After you do that, since we already know those new unit circle values, we will substitute the angle measures into the correct formula and then replace them with the trig values from the unit circle. And then my hint to you is that you might find it easier to do the problem in degrees. So if the problem's in radians, you can convert to degrees and do the problem in degrees, just because it's a little bit easier to understand. So let's see some examples. Here's my unit circle that I'll be flipping back and forth to. My first example, I want to find the exact value of cosine 75. So I want to point out that exact value is not a decimal. So simply typing in cosine of 75 into your calculator, and I am in degree mode, I already checked. So simply typing in cosine of 75, that gives you a decimal. That decimal is not an exact value. You can see it keeps going. It's not a terminating decimal. When I say exact value, I'm talking radicals. So how do we do that? I'm about to show you. This, however, would be a correct answer. It's just not the exact value that they want. So cosine of 75. I'm going to get that cosine formula that I gave you earlier. It looked like this. So that's the first thing, get the formula written down. Now, I want to rewrite 75 as the sum of two special angles, or the difference. So if I flip back to my unit circle, I can make 75 by adding 45 and 30. 45 plus 30 is 75. So that's what I'll do. There could be other correct answers, like maybe what is it, 75, 120 minus 45. So that would work too, but I'll stick with the 45 plus 30. You'll get the correct answer with whichever one you choose. So I'm going to use this sum formula and find the cosine of 45 plus 30 instead of finding the cosine of 75. It's actually the same thing. So by plugging in the angle measures into the formula, that's going to leave me with cosine 45, cosine 30, minus, because it's the flipped one, so it means if you use plus here, use the opposite here, sine 45, sine 30. Okay. Now, your next step is to plug in the actual trig values for these four things here. So cosine 45, cosine 30. Looking at the unit circle, the cosine is the x value. So the cosine of 45 is root 2 over 2, and the cosine of 30 is root 3 over 2.
Okay. Was there anything else you wanted to say about that?
Sine 45, sine 30. Sine is the y value, so root 2 over 2, 1/2.
I was just going to ask if this is, some people it is their pet.
Okay, once you plug in the trig values, the rest of it's algebra and simplifying. So multiply root 2 times root 3 is root 6, so root 6 over 4, minus root 2 times 1 over 2 times 2 is 4. And luckily for us, they already have a common denominator, so we'll keep it. And our numerator is root 6 minus root 2. So this is going to be my exact value for the cosine of 75. It is exact because there's no decimals, there's only radicals and fractions. I can check my answer and make sure it matches up with the original decimal I got by doing root 6 minus root 2 over 4. And you can see that my answer matches up, so that is a way of us doing a self-check to see if you have your answer correct. Okay, let's do some more examples. Our next one is the sine of 19 pi over 12. So I gave you that helpful hint that it's often easier to work in degrees. So I'll just go ahead and convert it to degrees by multiplying by 180 over pi. The pi's cancel. So 19 times 180 divided by 12. And that's 285 degrees. So I want to find the sine of 285 degrees. So let's go back to the unit circle and find two angle measures that add or subtract to 285. 285, 285. We're here in the fourth quadrant. So what about 330 minus 45? Does that give us 285? 330 minus 45. It does. So I'll use that. There's probably other options you could use, but just be sure you use two numbers from the unit circle. So 330 minus 45 is what I'm going to pick.
One of them must be 90. So one of the angles must be 90. So the Pythagorean here is for right triangle. Okay.
Okay, so back to my formula to plug everything in. That would be sine 330 cos 45.
Given that you've got the two other sides, you can put them in the equation. Are there any questions that you had on the Pythagorean theorem?
Minus, because I used a minus here, so I used the same sign here because the symbols are the same and not flipped. So minus cosine 330 sine 45.
So what we're going to do together, I would like you to graph the equation y equals x squared minus 3x minus 28. So go ahead and graph. Right, x squared.
Okay, so let's find these trig measures using our unit circle. Sine of 330 is negative 1/2.
So, well.
Cosine of 45 should be root 2 over 2, but we'll double check it. Yep.
This one, we're not going to do the square. So, do you have that up on your graph?
Minus cosine of 330, root 3 over 2, times sine of 45, root 2 over 2. And let's simplify. So that would be multiplying negative root 2 over 4 minus root 6 over 4. They have a common denominator, so we can combine even further. Negative root 2 minus root 6, you can't combine them. You gotta leave them separate. And that would be our final answer. So I'm gonna end this video, and in the next video you'll get to see an example of a tangent problem, and you'll get to see an example of rewriting as a single trig function, as well as some practice.